Hello everyone and welcome back again to my channel. I hope you remember what we did yesterday on real numbers. So we will continue on the another later part of it on real numbers and we'll finish it. And you will understand the importance of the concepts which we did yesterday, practice more on it and you will get perfection. So without too much further ado, so let's begin. I hope if we start recalling, you will tell me that what is a real number. So you have seen that there is a big flow chart, what we have done yesterday. So we will begin with that. So basically, we will start with rational and irrational. So rational and irrational numbers together make real numbers. And in grade 9, you have done a lot on it. So uh, what you all have done, can you tell me? Let me say it. So you all have done on irrational numbers and their properties. And also in grade 9, you have done how to locate irrational numbers on number line. So today you're going to prove those irrational numbers. So root 2, root 3, root 5, how they are irrational numbers. So you're going to prove that. And you will understand the decimal form of irrational numbers as well as rational numbers. So today we will start with the decimal form. And I hope you must have done in grade 7 and 8 also, that how do you say decimal form of it. So there are certain decimals which terminates. If I simplify, terminates means ends. Okay, so if I say right now to you that 1/2. Now 1/2, when you write in decimal, it will come as 0.5. And this will end. You will get a remainder as 0. So this one is also a rational number, right? So there is a certain number like 1/3. Now, when you do decimal form for this, it will come as 0.33 and goes on and on. It will not end. So for that, what you do? So you call this as non-terminating, right? Which is not ending. So which ends, which is ending, it is called as terminating. And which is not ending, it is called non-terminating. Okay. But here there is something, it is not terminating, that is right. But something is repeating. So what is repeating here? It is 3 which is repeating. So then we know that how we are going to write. We can write somewhere like this 0.3 and there is a small bar on it, which means that this digit is repeating. Okay, so rational numbers you can now understand in the form of, again it is fluctuating. So rational numbers you can say as those numbers which terminates. Like an example we have seen as 1/2. So that terminates. Okay, so terminating decimals are rational numbers. So one recognition is this. So you get any decimal, you will understand this is a rational number. When you get simple 0.5, 0.2, 0.125 or anything, which ends. But there are certain rational numbers where you see some digits are repeating. Okay, so what are those? So those numbers are like 0.3 bar or something as 0.15 bar, maybe 5 is repeating in this case. Okay, so there are certain cases like this. So understand, rational numbers are those numbers in decimal form we are talking about, that the numbers which are terminating, and if it is non-terminating but repeating decimals, or you can say recurring also. So when you read in your textbook, sometimes it is called as recurring. So recurring means repeating. So non-terminating but repeating, and the another part terminating decimal. So both of them come under as rational numbers. But there are certain decimals which are non-terminating and non-repeating. That is called as irrational numbers, and our value for pi 3.14. This will also go on, and the digits are not repeating. So this also considered as an irrational numbers. So today we will see that how without dividing also you can recognize, you can identify that this number is terminating, this number is rational or this number is irrational by identifying the decimals. So let's move on to the next part. I hope this is clear. Let's revisit again. So terminating decimal and non-terminating but recurring decimals are rational numbers. And the another part, non-terminating and non-repeating are irrational numbers. So you will recognize it nicely. Now, the another part, if you see, when I say prove root 5 is an irrational number. So here, your fundamental theorem of arithmetic, what we were talking about yesterday, is going to use here. So you will start that any root 5, root 3, root 2, how they are irrational numbers. So whenever you have to begin, you always begin with that. Suppose they're irrational, okay? We have to prove irrational, so we will assume that suppose this is irrational number. So we will always say, suppose it is irrational. We have to assume it. Let root 5 is rational. Second, as soon as I do a dash, it goes to the other side. Yeah. So we will assume that this one is rational number. So when we say rational number, by the definition of rational, it means I can write in the form of numerator and denominator. Yeah. So you say root 5, I can write as x upon y. I can write, yes. When I say rational, that means it can be written in the form of p by q. Now, what are these x and y? We will say this x and y are co-primes. How many of you remember what is co-prime? I'm writing co-prime. How many of you remember that? Co-primes are those numbers which have only HCF as 1, highest common factor as 1 and nothing else. Like if I say 2 and 3, HCF is 1 only. Or I say 3 and 4, HCF is 1 only. 4 and 5, HCF is 1. So any two numbers which have their HCF as 1, they are called it as co-prime. So I'm assuming that suppose root 5 is a rational number. So I can write it as x upon y. That's correct. Now I have to further simplify. Now for that, I will be doing, I hope you have learned this, that if you get something in a form of equation, you cross multiply. So y root 5 is equal to x. Can we write like that? Any other problem? I hope you understand cross multiplication. You multiply with that and then you multiply with this. Yeah. So x is equal to y root 5. Now, how do I further simplify? So what I'm going to do, I will do squaring on both the sides. So, excuse me. So squaring on both the sides, right side as well as the left side. So when I do squaring means y into y. Okay. So y into y, it becomes y square. And root 5 into root 5, that becomes 5. I hope you have done in squares root in grade 8 and 9 also you must have done. So square root of 5 into square root of 5, that becomes 5. So I can write as 5y square is equal to this squaring is done on the left side. Now on the right side there's only one x, so that becomes x square. Okay, so 5y square is equal to x square. Now if I have to make a meaning out of it, what does it mean? So if I have to make a meaning out of it, that means I can say y square is equal to, again it has gone to the other slide. Okay, so I can say here x square upon 5. What does it mean? It simply means that x square is divisible by 5. If I have to rewrite again, it means that x square is divisible by 5. That means x is also divisible by 5. So we will say that this is my first equation. Okay, so I will say this is my first equation. So everyone has to remember and learn it. Something you need to prove as irrational number, you have to start with that it is a rational number. So when something is rational number, that means you can write in the form of p upon q. Now when you write in the form of p upon q, which is a fraction, then you write as x upon y, a upon b, any variable you can take. So there is no hard and fast rule. I have to take x and y only. You can take anything. Then afterwards, you simplify, square on both the sides, and then you will come to a conclusion when you say that y square is equal to x square upon 5. And it simply means, you can say that x square is divisible by 5. X square upon 5, it means this. That means x is also divisible by 5. Okay, so now this is your first equation. Now again, we will take, after that, we will take again, now after this, we will say x, okay? We will assume, we have to assume a lot in this. So we will say, let x is equal to 5k. Now we are assuming, okay? So we got something over here after that first, and we will say x is equal to 5k. Now, when you say x is equal to 5k, what do you have to do with this x? You have to put the value of x in first equation, okay? So what is my first equation now? Now, understand, you have to put the value of x. You can write, in a more defined word as substitute. Substitute the value of x in first equation. Substitute the value of x in first equation. Now, what will happen? This will happen. Y square is equal to, what do you have? 5. 1 second. 5 upon 5. Okay, x square means 25k square. It simply means this, right? So it can divide. So you have y square is equal to 5k square. You got this, something like this. What does it mean? And you can further say y square upon 5 is equal to k square. You can write down in the next step, yeah? So what does it mean? Here, you can say that y square is divisible by 5. That means y is also divisible by 5. So if you see your first and second equation, when you say that x and y are co-prime, that concept has become wrong. It's contradicting, because in first equation, it means that x is divisible by 5. It means this, okay? And here you are saying, second again, it goes. Okay, so here you say that y is divisible by 5. Can you see both? It's so clear. So your first equation says that x is divisible by 5, and your second equation says that y is divisible by 5. That means both have something common, that is 5. And we have assumed in the beginning that x and y are co-primes. Now, co-prime is there is nothing common, HCF is 1. So that means our assumption is wrong. Root 5 is irrational, and we have to write towards the end here somewhere, wherever you get it. So we are contradicting. You will say our assumption is wrong. You have to write it. We have to write down somewhere our assumption. Assumption means what you have assumed in the beginning. Our assumption is wrong. Our assumption is wrong. X and Y are not co-prime, then it means, so this means that root 5, and you will write in the answer, root 5 is irrational number. So this is one way of proving it, and this is something is given in your textbooks and everywhere. So you have to remember it anyhow. There is no way out, okay? So understand a basic concept, of rational number, and from rational number, you're proving to irrational number. And it's very easy. So once you remember with 1, any other question is given, you can do, whether it is root 3, root 2, root 7, anything, you can do it. So understand the first step, again, we are revisiting. First, that let root 5 is a rational number. Then you can write in the form of a upon b, p upon q, x upon y, simplify it, which will tell you that one of those numbers is divisible by 5. And then again, you assume from there that this, suppose this is equal to 5k, you substitute the value in the first equation and solve it. So you will arrive at towards where you have assumed x or y, whatever, that our assumption is wrong. So they are not co-prime. So root 5 is an irrational number. So that you need to write it. I hope this is clear, and practice it because it's very, very important. Yeah. So again, if you see here, we have another set of question, which is 3 plus 2 root 5 is an irrational number. So we have to begin with what we have learned. So if something we have to start with that it is an irrational, we have to assume let 3 plus 2 root 5 is a rational number. Okay. So we have to assume that it is a rational number. Now, when something is a rational number, then you know that it can be written in the form of P upon Q. So we will assume that 3 plus root 2 root 5 is equal to x upon y. I generally take x upon y because I'm in the habit of taking x and y. You can take a upon b, p upon q, anything, l upon m. So now we have to rearrange it. Now rearranging it means I will take 2 root 5 is equal to x upon y minus 3. So I'm shifting this 3 to the other side. And also root 5 is equal to this 2. When it goes to the other side, it becomes half of it. It is going to divide the other side. So this whole term will be divided by this 2. So we are writing like that. So what does it mean? It means that here this half and all this term says that it is a rational number. So when I say this part represents a rational number, and this is equal to this, it means that when in maths, when your one side represents something, that means it is equal to the other side. That's what equality means. So here, your right side, if it says it's a rational number, it means that root 5 is also rational number. Now, again, it's a contradiction. Yeah. Again, it is a contradiction. Again, it is a contradiction. Yes. So it means that it is not possible that root 5 is also a rational number. When we say one side is a rational number, so root 5 is also rational, it is impossible. Yes. So this is not possible. This is impossible. And again, we will say that 3. So it means that 3 plus root 5 is an irrational number. It cannot be a rational number. So I hope this is clear to you all. Again, all the same steps, but this one is quite easier than the earlier one. So start with the rational number, and again you change it into x upon y or p upon q, simplify it. So one side comes as rational number, which means the left side is also rational number, but this is impossible. So this means that 3 plus 2 root 5 is an irrational number. Okay. So I hope this is clear. Now we will move to the decimal expansion part. As I already told you that how to identify decimal part of rational and irrational number. So that is one thing. When it is terminating decimal, you can understand it's a rational. But sometimes what happened, they will give you, in the form of like this, you will see in your textbook 13 upon 3,125. So such kind of numbers without actually performing division, you have to tell whether you will get a terminating or non-terminating. How do you decide that? So such kind of things you will decide if the denominator has only factors 2 or 5 or both. Understand, I'm repeating again. So understand, this is a very important, something you will get in your objective type questions. So if they ask you simply such questions, how do you recognize they are terminating decimal or non-terminating? So if your denominator, the question which you get, its denominator is either 2 or 5 or both of them, then it is terminating. Otherwise, it is non-terminating. I'm writing again for you all to understand. Okay, so if you get your denominator 2 or 5 in this form or both or both in this form, 2 into 5, then it means that it is a terminating decimal. Otherwise, no. So when I say your first question, okay, I will check only the denominator. We will not bother about the numerator, what it is. So it is 3125, 3025. So when you factorize, when you factorize it, you will see that it will come as 5 into 5 into, I think, 5 into 5. So 25 into 25 is your 625. There is one more 5. So can you see your denominator? All of them are coming as in the form of 555. So definitely it is a terminating decimal. So you will put a tick mark in it. Now 17 upon 8. Now check the denominator. Denominator is 8. Now in this case, again it is 2 into 2 into 2. Only 2's. Again, it is a terminating decimal. Okay, so obviously it is a terminating decimal. So again, put a tick mark. Now third one, it is 455. Now 455, when you factorize it, it will come as 5 times and it will go 9 and then 1, then 9 and 1, it can go by 7. Then you will get 13. Now, other than 5, which two numbers you got? 7 and 13. Yeah. So it's not just 5. You have other than 5 also. So it is not a terminating decimal. So understand. So these three examples will give you an idea how to recognize. If you get 2, then only 2. Okay, only 2. Then it is a terminating decimal. If you get only 5, then it is a terminating decimal. If you get 2 and 5 both, 2 into 5 in that form, that is also fine, then it is terminating. But if you get other than that, like in your third example, then it is your non-terminating. So it is not terminating because other than 5, you got 7 and 13 also. Okay. So I hope this is clear. This is something very easy. Now let's move on to the next set of questions. Now after this, as I told you, identification as I have already taught you. So it's very easy. Now the first one, if you see, the first one, it ends 1, 2, 3, 4, whatever number it is, it ends at 9. And they ask you that if it is a rational number or not. So I think it is quite easy. It is a rational number. Answer is yes, because it is a terminating decimal. Now see the second one, 0.120, 1200, it is not terminating, it is not ending, and also it is not recurring, not repeating. So it is an irrational number. The first one is rational number. One second. Again and again, it is moving so fast. So, and the another one is irrational. Okay. And now here, see the third one, tell me what it could be. 43.1, 2, 3, 4, 5, 6, 7, 8, 9 is just like the first part. But what's the difference? The difference is there is a line above those numbers, those digits, and this is called bar, and it means that it is repeating. So all the digits are repeating after 9. Again, it starts with 1, 2, 3, 4, 5, 6, 7. It means it is not terminating for sure, but it is repeating. So such kind of numbers are your rational numbers, non-terminating but repeating again. Again, I'm saying it. So I hope all of you must have enjoyed today's class. That's something proving irrational numbers and also how to identify as rational or irrational in decimal form. So practice it again, because again, I'm saying it, that is something I believe in always, that practice makes a man perfect and permanent. So happy learning and keep practicing. And by then, all of you, rise and shine. Bye-bye. See you all.